Step into the world of revolutionary space technologies. This video showcases the key innovations that are actively shaping the next era of cosmic exploration. We'll break down the game changers: reusable rockets, advanced propulsion, orbital tugs, and intelligent robotic spacecraft. Learn how these developments will deliver faster, safer, and more sustainable access to space, fundamentally changing satellite deployment, planetary missions, and the future of human settlement off-world.
ESA is pioneering its future space transport ecosystem, a framework intended to make European space operations reusable, connected, and sustainable. This major initiative, driven by the Future Launchers Preparatory Program, moves away from disposable architecture and toward an integrated network. The system relies on the symbiotic interaction of reusable launch vehicles, space tugs, and orbital refueling capabilities, all utilizing standardized docking interfaces. The core principle is modular logistics. Spacecraft can refuel and service themselves, extending mission life and swapping payloads in orbit. This strategy supports critical technology efforts like booster recovery and advanced propulsion like thrust, best, and first drive, ensuring the viability of future reusable space transportation. A central infrastructure element is Odyssey, the proposed orbital service and refueling depot. Odyssey will not only store necessary propellant, but also provide satellite maintenance and prepare deep space missions destined for the Moon or Mars. By embedding reusability into its design, the ESA ecosystem is projected to achieve crucial outcomes, reducing operational costs, increasing mission frequency, and securing Europe's leadership in sustainable space logistics.
Rocket Lab's Neutron is set to redefine the medium lift category, offering a highly reusable rocket engineered for high performance and efficiency. This vehicle is capable of launching critical payloads up to 13,000 kilograms into low Earth orbit for commercial, scientific, and defense customers. Neutron's design prioritizes speed and sustainability. Its 43-meter frame utilizes a lightweight, durable composite structure and is fueled by clean liquid oxygen and methane, burned by the powerful Archimedes engines. Crucially, the rocket's first stage is designed for complete recovery and rapid refurbishment. It can execute precise landings either on land or via an ocean platform known as return on investment, or ROI. By combining significant lift capacity, a sustainable design, and rapid reusability, Neutron is positioned to be a major player in delivering satellite constellations and supporting crucial government and defense contracts.
ADRAS-J is a pioneering mission by Astroscale Japan and JAXA, focused on making space safer by tackling orbital debris. The spacecraft's goal was to prove that we can safely approach and inspect a huge, uncontrolled piece of space junk, specifically a retired H-2A rocket upper stage. Success in this mission is crucial because it validates the technologies needed for future debris cleanup. ADRAS-J uses advanced features like high-res cameras and smart navigation tools, such as recognizing the debris only by its shape and angles, to precisely track and analyze the object's movement. The spacecraft executed critical maneuvers perfectly, including initial fly-arounds within 50 meters and a tight approach to just 15 meters, confirming Astroscale's capability for extremely precise, safe operations near debris. The successful results from ADRAS-J are the essential foundation for the follow-up mission, ADRAS-J2, which will attempt to physically grab and remove the debris, marking a vital milestone for sustainable space operations.
The Atmos Phoenix capsule is poised to revolutionize space logistics by offering a safe, reliable way to bring payloads back from orbit. This capsule is specifically built to return up to 100 kilograms of high-value cargo like delicate biological specimens or material science experiments from low Earth orbit. The genius lies in its inflatable heat shield and atmospheric decelerator system. By expanding during re-entry, this inflatable structure acts as an aerodynamic brake, drastically cutting speed and protecting the payload from intense heat and stress. The Phoenix 1 prototype recently proved this technology works during a successful demonstration aboard SpaceX's Bandwagon 3 mission, where it fully inflated its heat shield and transmitted vital data under actual re-entry conditions. With all major systems confirmed, the focus shifts to the upcoming Phoenix 2. This next version will introduce onboard propulsion for precision landings, a larger capacity, and better communications. This innovation will establish Europe's first dedicated orbital return service, expanding both scientific research and industrial use of microgravity.
Blue Origin's New Glenn rocket is a monumental heavy-lift vehicle built to enable ambitious, large-scale orbital missions. At an impressive 98 meters in height, its sheer size is matched by its utility, offering a massive 7-meter payload fairing, the largest available, perfect for launching entire constellations of satellites.
The rocket's design is fundamentally focused on reusability. Its first stage, which Blue Origin intends to use for up to 25 flights, is driven by 7 powerful BE-4 engines, fueled by LOX and LNG. After separation, the booster executes a precise, controlled descent using aerodynamic features and landing legs, setting down on a specialized ocean platform 1,000 kilometers away. The upper stage is built for precision, employing 2 BE-3U engines that can perform multiple restarts to hit demanding high-energy orbits like GTO. Capable of lifting around 45 metric tons to LEO, New Glenn doesn't just launch cargo. It reinforces Blue Origin's commitment to making space access high volume and drastically more affordable.
Meet the Inversion Arc, the world's first true orbital delivery service, built to get essential cargo anywhere on the planet in under an hour. This reusable re-entry vehicle operates autonomously from low Earth orbit, offering unmatched speed for defense, emergency, and research missions. The Arc is defined by its operational flexibility. It uses advanced hypersonic maneuvering and a rugged landing system to execute safe, precise landings on both land and sea, no runway required. Inside its compact bay, it can transport vital payloads like medical supplies, communication gear, or drones. To withstand the trip, the Arc is a masterclass in aerospace engineering, featuring heat shielding, flaps, and thrusters that allow it to maintain stability and control while enduring intense thermal loads at speeds over Mach 20. Beyond delivery, the vehicle doubles as a hypersonic testbed. By maintaining a constellation of arcs in orbit, Inversion Space is building an immediate, reliable, and high-speed global logistics network.
Blue Origin's Mars Telecommunications Orbiter, or MTO, is set to become the backbone of Mars exploration, dedicated entirely to solving the challenge of high-speed data relay between the Red Planet and Earth. Utilizing the flexible Blue Ring modular platform, the MTO provides an unprecedented ability to maintain continuous, high-bandwidth communication across Mars orbiters, service missions, and home base on Earth. Key features include multiple steerable antennas and a broad beam transmitter for wide area coverage, plus smaller UHF satellites to extend the reach down to surface rovers and landers. The MTO is built for autonomy and longevity, featuring a hybrid propulsion system for mission flexibility and onboard AI processing for real-time data management and routing. By establishing this robust network, the MTO makes a crucial step towards securing the stable, scalable communication infrastructure necessary for both robotic expansion and future crewed missions across the Martian system.
Firefly Aerospace's Blue Ghost lunar lander is pioneering the future of commercial missions to the moon. Built for resilience and accuracy, the lander serves as a high-tech delivery vehicle for NASA's Commercial Lunar Payload Services program, transporting crucial scientific and technological cargo to the lunar surface. The Blue Ghost is a complete mission solution, managing everything from transiting space to operating on the moon. It features an efficient power system, using solar arrays to produce over 400 watts for its payload experiments. These experiments focus on understanding lunar challenges like dust movement, surface chemistry, and radiation effects. Engineered for the lunar environment, the lander utilizes a dedicated propulsion system for a flawless soft landing and advanced thermal management to maintain functionality despite drastic temperature swings. Visual feedback from its onboard imaging systems ensures the safe and precise deployment of all scientific packages. The Blue Ghost platform is highly scalable, promising future missions that include deploying rovers and laying the groundwork for a long-term human presence in deep space.
Pulsar Fusion's Sunbird is poised to redefine space exploration with its cutting-edge nuclear fusion rocket concept. This system is designed to act as an orbital fusion tug, attaching to spacecraft in low Earth orbit to power their journey into deep space. Sunbird's innovation lies in its dual direct fusion drive, which compactly integrates propulsion with an onboard power source. The targeted 2 megawatt output provides both rapid acceleration and ample electrical power, enabling the use of advanced scientific equipment. The key metric is its projected specific impulse, ranging from 10,000 to 15,000 seconds, which is high enough to dramatically shorten transit times. For instance, launching a 1,000 kilogram payload to Pluto in under 5 years. By harnessing fusion, the system bypasses the need for solar energy, guaranteeing high-speed travel and strong operational capability even at the solar system's furthest reaches.
The Dassault VORTEX program is France's strategic answer to the demand for sustainable multi-mission access to space. Envisioned as a fully reusable spaceplane, the Vortex will serve a dual purpose for both military and civilian applications. Its core advantage lies in its ability to operate in orbit, launching cargo, repairing satellites, and conducting complex maneuvers, and then return to land directly on Earth's runways, much like a conventional aircraft. The path to full capability begins with the Vortex-D demonstrator, a crucial 1/3 scale model testing the most challenging hurdles, such as surviving the heat of hypersonic re-entry and perfecting complex flight controls. The Vortex is designed for versatility. Its modular design allows it to switch rapidly between different tasks, from retrieval missions to cargo delivery. Supported by the French government and European partners, the Vortex concept is poised to dramatically reduce the cost of space operations while providing Europe with an unprecedented level of independence and mission flexibility.
From highways to high orbit, Honda's leap into reusable rocketry. Honda R&D is pushing the boundaries of engineering, transitioning from its automotive roots to pioneering aerospace innovation with an experimental reusable rocket. This project aims to master vertical takeoff, stable flight, and pinpoint landing, essential elements of modern space travel. Honda is tapping into its deep reservoir of knowledge in combustion, propulsion, and automated vehicle systems to create reliable control algorithms for true reusability. This striking prototype is 6.3 meters tall and weighs about 1.3 tons when fueled. Its recent test flight at the Honda Tiki facility in Hokkaido was highly successful. It soared to 271 meters, flew for 56 seconds, and demonstrated remarkable landing precision, touching down within 37 centimeters of its designated target. The rocket employs advanced thrust vectoring and autonomous guidance for smooth control and recovery. Though currently a research effort, the company has set an ambitious long-term goal, achieving suborbital flight by 2029, positioning Honda as a serious contender in the future of reusable rocket technology.
The search for life is entering a new era, defined by NASA's expanded vision of a habitable solar system. This effort looks for places where conditions support liquid water, and thus biology. To guide the search, scientists rely on the concept of the habitable zone, the distance from a star where a planet's surface can maintain water in a liquid state. This grand endeavor is anchored by the Habitable Worlds Observatory, HWO, a massive new space telescope. HWO is specifically designed to suppress the glare of distant stars and capture direct images of exoplanets. Once spotted, it will hunt for atmospheric clues or biosignatures, like oxygen and methane, that might suggest life. Together with advanced climate models that redefine habitability and local missions studying moons in our own backyard, NASA is systematically aiming to uncover life's potential, both near and across the galaxy.
Led by Jared Isaacman, the Polaris Dawn mission represents a major leap forward for private orbital spaceflight and SpaceX's ambitions in commercial human exploration. The 4-member crew launched aboard the Crew Dragon Resilience, ascending to a stunning orbital altitude of roughly 1,400 kilometers. This path was deliberately set to traverse the challenging Van Allen radiation belt, providing crucial data on radiation's impact on human physiology and equipment. The mission made history by performing the first ever commercial spacewalk, or EVA. The crew used and evaluated SpaceX's newly designed EVA suits, specifically built for vacuum operations and superior movement. Over 5 days, the astronauts executed significant biomedical and scientific research, focused on human adaptation to microgravity and essential decompression safety. A key technological component was the testing of Starlink's laser communication systems, proving data transfer capabilities vital for long-duration journeys. Polaris Dawn is the foundational mission of the series, preparing humanity for future deep space exploration, including crewed trips to the Moon and Mars.
The Starship mission is SpaceX's boldest venture, setting a new bar for humanity's pursuit of interplanetary settlement. This powerful vehicle is a fully reusable, 2-stage system, pairing the massive Super Heavy booster with a multi-purpose upper stage designed to carry large crews and cargo into deep space. Under Elon Musk's leadership, the long-term objective is clear: to establish a sustainable human civilization on Mars. The phased approach begins with robotic landers, which will validate critical technologies like atmospheric entry, landing procedures, and the essential in-orbit refueling needed for deep space transport. As the program matures, missions will expand to include life support testing, habitat installation, and the infrastructure development necessary to support permanent residence. By capitalizing on advances in reusability and autonomy, Starship is the foundational element that will realize the vision of a self-sustaining Martian city launched efficiently during optimal planetary alignments.
Meet the JAXA HTV-X, the future of Japanese space logistics. This next-generation cargo vehicle takes over from the reliable HTV, but elevates its mission by seamlessly blending routine ISS resupply with powerful, long-duration technology demonstrations. The HTV-X is built for maximum flexibility and efficiency. Massive payload. It can carry significant loads with a capacity of 4,070 kilograms inside and an additional 1,750 kilograms of exposed, unpressurized cargo. Time-critical delivery. Its most operationally important feature is the ability to accommodate cargo loading just 24 hours before launch, ensuring that scientists can send the freshest possible experiments and supplies to the crew. Extended missions. After delivering its payload, the HTV-X is a workhorse capable of remaining berthed at the ISS for half a year and performing autonomous orbital demonstrations for up to 18 months after undocking. With a simplified, reliable propulsion system and continuous data flow secured by advanced communication networks, the HTV-X is more than just a freighter. Its adaptable architecture is designed to support future space infrastructure, setting the stage for more versatile and cooperative long-duration operations in orbit.